Welcome to Analytics Mastery Academy. My name is Kunal. This video covers Section 7, Governance and Security. We will go through managed versus external tables, the Unity Catalog security hierarchy, privileges, and row and column level security. Let's start with managed versus external tables because this distinction is guaranteed to show up on the exam. With a managed table, Databricks owns both the metadata and the data files. Running the drop table removes both. This is the default behavior when you create table without a location clause. Managed table data lives in the Unity Catalog managed storage location, which is defined at the Metastore or catalog level. Use managed tables when you want Databricks to fully own the lifecycle. It's the simplest setup with no external storage configuration required. With an external table, Databricks only owns the metadata. The data lives in the storage you control. The drop table here removes only the metadata. The data itself stays on the cloud storage. You define the storage path with a location clause like create table T and followed by the location. Use external tables when data needs to be shared with other tools, or when you need to control over the data retention, or when you are migrating from an existing storage. The critical difference to remember is that drop table on a managed table deletes the data, whereas the drop table on the external table leaves the data alone. That's exactly why sensitive production data often lives in external tables, so an accidental drop doesn't destroy anything. You can convert between the two using the create table as select or by redefining the table type. Now let's look at how Unity Catalog structures permissions. The hierarchy runs top-down. Metastore, then catalog, then schema, then a table or view, and then finally a row or a column. Permissions cascade down, but they can be overridden at lower levels. Principals come in three types: users, which are individual logins; groups, which are collection of users; and service principals, which are machine identities used for automated jobs. The grant syntax looks like this. Grant select on a table catalog.schema.table to a user. You can specify the privilege, the object, and the principal. Revoke works the same way in reverse. Revoke select on table catalog.schema.table from the username. Removes the particular privilege that you want to revoke. Then there is a deny. Deny select on a table T to group analysts explicitly blocks access even if the user would otherwise inherit through a group. Deny always overrides grant. Best practice is grant to the groups and not the individual users. To change someone's access, add or remove them from a group. Don't go update individual grants one by one. This deny overrides grant rule is critical for the exam. If a user belongs to group A, which has a select, and also belongs to group B, which is denied, the user cannot access the table. The exam tests this exact scenario with multi-group membership. Always manage access through the groups. Let's go through the core privileges. Select, read rows from a table or a view, the most common privilege required for any query. Modify. Covers, insert, update, and delete on a table, needed for any ETL pipeline that writes to the tables. Create table. Create new tables within a schema, typically granted to data engineers, not analysts. Create schema. Create schemas within a catalog. It is usually reserved for data engineers and admins. Usage. Required to actually use a catalog or a schema. Think of it as a traverse permission. Without usage, you can't access objects even if you have a select access on them. All privileges grants everything available on an object. Use this sparingly. The principle of least privileges applies here. Usage is a common exam trap. Select on a table isn't enough on its own if the user doesn't have a usage on the parent schema or catalog. Now let's cover fine-grained security, masking and row filtering. Column masking replaces sensitive column values. Things like social security numbers, credit card numbers with a masked version, like null, a hash, or a partial value. This is applied transparently at the query time. In SQL, you would create a masking function like create table function mask SSN followed by the SSN string, and then apply it with alter table t alter column SSN set mask SSN. From that point on, users automatically see the mask value. Row level security filters rows, so each user or group only sees the rows they are authorized to see, implemented through row filter policies. The SQL pattern looks like what you see on the screen. Both of these are part of Unity Catalog's ABAC, attributes-based access control approach. Policies are defined once and applied to any table, which centralizes row filtering and column masking instead of scattering logic across views. The result is dynamic data masking. Different users see different versions of the same data from the exact same query. No separate views are required. This is the modern alternative to building separate views per user group. Instead of maintaining two different views, you have one table with a row filter that automatically returns the right rows for each person. It's cleaner, more auditable, and easier to maintain over time. Let's go a bit deeper into the ABAC, right? Attribute access control. Attribute access control makes security decisions based on attributes of the user, the data, and the environment rather than the identity alone. Centralized policy management means you define row filter and column masking policies in one place and apply them across multiple tables, not per table view is required. Policies are evaluated at the query time. There is no data duplication. The same physical table serves different logical views depending on who is actually querying it. Inside policy expressions, you can use functions like is, account group member, current user, or other custom context functions to reference user attributes. Every policy evaluation is logged for audit and compliance. So you always know exactly who queried what data and what version of the data they actually saw. Common use cases include PII masking for analysts who aren't authorized to see it, regional data filtering for GDPR compliance, and tenant isolation in multi-tenant architectures. ABAC is the enterprise-grade approach to data security. For the exam, the conceptual question is what makes ABAC different from simple grant and revoke? So ABAC is dynamic. The same query returns different results for different users based on their attributes. It's policy as a code, centrally managed and automatically audited. Now I will recap section 7 that we covered today. Manage tables. Databricks owns both data and metadata. Drop table will delete the data as well. External tables. Databricks only owns the metadata. Drop table will keep the data in your cloud storage. The full access chain is usage plus select plus any needed create privileges. Deny override grants. Even if a user inherits select through a group, a deny can block it. Column masking and row level security delivered through ABAC policies are transparent, centralized, and obviously auditable. Next up in the video 8, we will talk about exam strategy and mock quiz, which is the last video of this series. See you there. Thank you.